The current landscape of business automation is built on simple trigger action connections, where one event in a software application initiates a predefined step in another. While platforms like Zapier and Make have made these integrations accessible, they remain rigid and require manual updates whenever a software interface changes. The integration of artificial intelligence is beginning to reshape this landscape, moving us toward a future of dynamic, self-correcting workflows. In this video, we will analyze the future of no-code AI workflows and examine how small teams can prepare for these structural shifts. We will cover three major trends: the transition from static automation to autonomous agents, the integration of semantic databases, and the principles of building resilient, model-independent automation systems. We will explore how these solutions address common bottlenecks, such as manual database updates, API configuration failures, and prompt drift. By focusing on practical application rather than novelty, you can make informed decisions about where to spend your automation resources. Rather than focusing on distant predictions, we will analyze the technical frameworks that are emerging today, giving you a practical blueprint to build systems that remain relevant as the technology continues to mature. First, let us examine the transition from rigid, trigger-based automations to autonomous agents. Traditional automation systems require you to map out every single step of a process manually. If a customer fills out a contact form, the system must follow a fixed path: send an email, create a spreadsheet row, and send a Slack message. If any step fails or if the customer's input is formatted incorrectly, the entire workflow breaks. The future of no-code workflows lies in agentic architectures, where you define a high-level goal and allow the AI to determine the execution steps dynamically. Instead of configuring a multi-step Zap, you instruct an agent to onboard this new client using our standard guidelines. The agent analyzes the client's input, determines which systems need to be updated, and executes the tasks. It can write draft emails, create tasks, and verify that the client has received the onboarding package. This shift makes workflows highly flexible, as the agent can handle variations and edge cases that would break a traditional automation. For instance, if a client submits their phone number in an incorrect format, the agent can recognize the error and ask for clarification, rather than passing broken data down the pipeline. This makes it easier to work on projects where you need to check how multiple modules interact. Since agentic systems operate with more autonomy, you should implement strict logs to track their decisions. Setting up audit trails allows you to review the exact inputs, thoughts, and actions taken by the agent. This is critical for debugging when the system outputs unexpected results, ensuring you maintain control over your business processes. To build these systems, creators must learn how to configure memory buffers and state machines, ensuring the agent remains on task and operates within defined logical boundaries. Second, we turn to the integration of semantic databases and vector stores within no-code systems. Most business data is unstructured, consisting of emails, chat logs, customer feedback, and text documents. Traditional databases struggle to process this information because they rely on exact keyword matches. Semantic databases, which use vector embeddings to represent the meaning of text, allow no-code workflows to search and query unstructured data based on concepts rather than keywords. In the future, no-code platforms will feature native integrations with vector databases, allowing your automation systems to access your company's full knowledge base in real time. For example, when a customer submits a support ticket, the system can automatically convert the query into a vector, search your internal documentation database for semantically similar answers, and generate a draft response containing the exact solution. This process, known as retrieval-augmented generation, ensures that the AI has access to current, relevant information without needing constant model retraining. Using semantic databases also simplifies the process of onboarding new customers. Instead of asking them to fill out long forms, they can describe their requirements in plain text. The system can parse this raw input, identify key requirements, and match them with corresponding service options in your database. This reduces customer onboarding time and provides a more intuitive, conversational experience. Small teams can prepare for this shift by organizing their internal documents into clean, text-based formats and establishing clear naming conventions. By structuring your business data today, you ensure that future semantic search systems can index and retrieve your information accurately, providing a significant operational advantage. Finally, we must discuss the principles of designing resilient, model-independent workflows. As artificial intelligence models continue to update, relying on a single model provider presents a major operational risk. If a provider changes their pricing, updates their model's behavior, or experiences an outage, your business workflows can fail instantly. To mitigate this risk, future no-code architectures must be designed to be model-independent. This means structuring your automation pipeline so that you can switch the underlying language model, from Claude to ChatGPT or an open-source model, with a single configuration change. To achieve this, you should separate your prompt instructions from the execution code, storing your prompts in a centralized database rather than hard-coding them into specific app steps. Furthermore, you must build robust error handling and fallback systems into your workflows. If the primary model fails to respond within a specific timeframe, the system should automatically route the task to a secondary model. Another benefit of model-independent design is the ability to optimize for cost and speed. For instance, you can use a smaller, faster model to handle routine categorization tasks and save the larger, more expensive model for complex writing and reasoning. This tiered architecture keeps your operational costs low while maintaining high quality. Building fallback paths also ensures your system continues running during regional API outages. You must also monitor rate limits and token usage to prevent your automated systems from being blocked during peak hours. By building redundancy and flexibility into your automation architecture, you can design workflows that remain stable, cost-effective, and resilient, regardless of which model provider dominates the market. Signal Stack AI helps professionals, creators, and small teams understand the AI tools that actually matter. Each video breaks down one workflow, one tool category, or one automation strategy without hype, jargon, or fake promises. If you want to save time, build smarter systems, and stay ahead of the AI curve, this channel gives you clear, practical explanations you can use immediately. This video is general technology education, not a guarantee of productivity gains, software stability, or business revenue. AI tool features, pricing, and terms of service change frequently.